We'll start recording. Thank you. Okay. Yeah. So for anybody that hasn't joined before, we're the Extenders Club, and it's a community of R programmers and package developers and data visualization enthusiasts. And we just hold like virtual meetings every couple of months to talk about ggplot2 extensions and motivations and design choices. Um, so we can get started without further ado. Matthew is um, a macroecologist and data scientist seeking to understand the mechanisms underpinning plant biodiversity and responses to global environmental change. His research spans biotic scales ranging from genes to species to ecosystems. In addition to empirical studies, he develops modeling and visualization tools to help inform conservation and management. So with that, I'll turn it over to you.
Let's see.
Okay,
I sent a
I'm muted.
request to share
Okay,
there.
yeah, well said.
Awesome. Um, can you all see my slides there?
Yeah,
Cool. So yeah, ggcube. This is a new package just released to Crayon a couple months ago. I've been working on it for a few years as a side project, just kind of like tinkering with it for a couple days, setting it aside for a couple months, kind of thing. As Gina said, I'm uh, an academic ecologist, so this is very much a side project and kind of a fun diversion for me. Um, the origin of the package. So basically, I needed 3D figures for my own work. I do a lot of visualizing, like multi-dimensional statistical model response surfaces and geospatial terrain and other sort of three-dimensional type objects. But I love ggplot and I wanted to make these kind of plots in ggplot. Once you're deep in ggplot, like every other visualization system kind of seems cheap and unsatisfying. So I started playing with like ways I could make 3D figures using ggplot. Initially, I was like manually projecting my own three-dimensional data, constructing custom like axes, projecting those using the same like linear algebra, and then plotting those using base ggplot2. It worked, but it's kind of laborious and hackish and wasn't really like an efficient system moving forward. I realized that if I wanted to actually implement this in a way that was useful for myself and others going forward, the right way to do it was by creating a new chord, right? Chords are obviously the way that ggplot intends these types of transformations from raw data space into visual space to happen. And that was obviously the right sort of ggplot uh, idiomatic way to implement something like this. Um, so that was kind of the goal and the motivation. That being said, it was a long process, and ggplot's not really designed to add new positional scales, so there was a lot of things I had to figure out along the way. Um, Also, no like talk on 3D visualization is complete without the important caveat that 3D is most of the time not the right choice, particularly if you're aiming for like precise quantitative communication, right? It suffers from occlusion and perspective distortion, and these things can make it hard for a viewer to actually interpret the values appropriately. There are a number of ways of helping mitigate that, but usually a two-dimensional plot is all you want. And there's plenty of examples of bad 3D graphics you can make using ggcube as well as other systems. So kind of a use responsibly disclaimer. But 3D obviously does have plenty of good uses as well. There's a lot of data that it's sort of genuinely three-dimensional, where 3D can be useful as well as being useful for storytelling and art and data exploration things. Um, So that's kind of the background. As I said, I've kind of been just tinkering with the project on and off for a few years. There were a couple of hurdles that finally, with the help of AI in the last year or so, I was able to clear up and get the package to a point to where I was like ready to actually release it on CRAN. So it came out a couple months ago. And yeah, I'll spend a couple minutes just kind of giving an overview of what ggcube is, what it can do, and then for the second part of the talk, dig into some of the sort of internal computations that happen in the pipeline and the way that I had to solve some of the problems that I encountered during dev. So here's a minimal example of a ggcube figure, right? It's a basic ggplot. You make a ggcube figure by adding a Z aesthetic, by using a dedicated 3D layer function. So the package has a variety of different geoms and stats that create the 3D layers that are needed. Most of the machinery and magic happens in this chord 3D. That's really the core of ggcube. And then there's some other features like adding light to add shading to the scene and things like that. And I'll kind of step through each of these pieces in a bit more detail here. Um, so ggcube masks ggplot's aesthetic with its own version that allows Z to be a positional variable, right? So there's plenty of other cases where you can declare Z, but it's nice to be able to just declare it positionally the way in base ggplot you can for X and Y, right? So here, for example, in this figure, we don't have to say Z equals bill length. We can just say bill length in the third position. But the masked ggcube version still works with ggplot, so it doesn't really like clash if you have both loaded at the same time. Um, then the chord 3D is, as I said, really the core place where all the three-dimensional machinery happens. It's this chord 3D function that you add to the plot, just like you would add chord polar or chord Cartesian or SF or whatever. And this is where all the parameters that determine like the 3D view live. So you can control the rotation, the perspective projection. You can control the scale ratios and scale expansion here. You can turn on and off different panels, right? The cube has six facets, six panels to that bounding box. You can switch those on and off or just accept the sort of automatic defaults. So that's kind of the basics of how you interact with chord 3D. Then I ended up having to create a bunch of dedicated 3D layer functions to work in this system. Some native ggplot2 layer functions work with ggcube, like geom_point works, but for the most part, they're not as fully featured as these native 3D versions. So most of these come with a stat as well, along with the geom, but it includes things like points and lines, volumes, and surfaces. I'll give example of a few of these. So geom_point 3D is the 3D analog to geom_point. It has a few differences. First of all, it scales the point size according to how far away it is. So more distant points appear a little bit smaller. The points plot in depth order, so nearer points plot on top of more distant points. And then you can also add reference lines that sort of add these dropper lines showing where on a two-dimensional panel surface each point lies, and that helps the viewer kind of orient a little more precisely where in three-dimensional space points are. Geom path 3D and geom segment 3D are the line aesthetic or the line layer functions. Again, you can use them to create three-dimensional paths. Here's an example of just a spiral, but you can see here that it handles on the back end automatically, making sure that the nearer parts of the path render on top of the more distant parts of the path. And also you can see they appear a little bit larger because of the depth scaling that happens. Surfaces are probably like the richest and most complex area of the layer functions in ggcube. This is the original motivation for the package, and there are a number of stats and geoms that can work sort of interchangeably. So there's 4 surface stats in ggcube. Stat surface 3D just takes a grid of x, y values, each with a z value, and plots it directly. Stat function 3D is the analog to stat function in native ggplot. If you just specify a function that has z as a function of x and y, and it will render it as a surface. Can also fit smoothing models, much in the same way that stat smooth and geom smooth do. Here we're looking at a model, right? We're at the confidence interval being displayed by additional layers rather than by like a shaded ribbon. And then stat density 3D also fits a kernel density estimate and visualizes that as a surface. So these different stats can all work with different geoms that are different ways of visualizing a surface. So there's basically 3 different geoms that can show a surface where z varies as a function of like a graded xy space. Geom surface 3D here on the left just fits like a tessellated set of polygons. Geom contour produces this layer cake of contour polygons, and then geom ridgeline kind of slices the surface horizontally in a ridgeline plot. Moving on, then we also have rectangular prisms. So we have bars and columns for 2-dimensional histograms. We have a voxel geometry for voxel, basically a 3-dimensional pixel. So you can visualize any arbitrary 3D volume using voxels. Also have hulls that are sort of defined by these closed 3-dimensional shapes that are fit to a point cloud, basically. So if you have a cloud of XYZ points, you can fit a convex hull or an alpha hull to those points in ggcube.
I wonder if we could take Harriet's question
Sure, yeah,
before
I
we.
don't actually have it on my screen at the moment. Can somebody
Oh
read?
yeah. She says, if you do a size adjustment under the hood, what happens if the user provides their own size aesthetic? So this was like a few slides back. Um, so if that.
Yeah, so for example, like for point size or for line width,
Mhm.
the size of the rendered point is based on the user specified size, and then it's just adjusted. So like in the middle of the cube, it's going to be exactly the size that the user specified when they call the plot function, and then nearer points are slightly larger and more distant points are slightly farther. And that's based on sort of one of the parameters in the 3-dimensional coordinate system is the distance to the plot center. And so there's actually like just a straight calculation where closer points are larger. And that behavior can be turned off too if you just want uniform size. Also have text. There's 2 different kinds of text in ggcube. This is showing polygon text, which is sort of the text is converted to polygons, which can then be rotated and projected in 3D space. Also have billboard text, which is just sort of a simple text layer that always faces the screen. So that pretty much covers the basic range of layer functions. There's also a couple of like layer adjacent features. Annotation here has to happen within the call to a layer function. So here I'm showing like geom surface 3D, and then within that, annotating it. And that's because the annotations have to be sorted within an individual layer as far as depth, right? So ggplot can't do its like depth sorting between multiple layers, right? A layer that gets added to the plot later is always going to render on top of a layer that was added earlier. So I'm able to like sort things by distance to the viewer within an individual layer function, but not across functions. And so an annotation that you want to sort of sort with the data has to be added within the layer function like I'm showing here. Um, Another thing you can do is like collapse data onto one of the cube faces. So I have this position on face position, and you can call any geom and specify that the position is position on face, and it will collapse the data all onto a cube face. And this is one strategy for helping mitigate some of the downsides of three-dimensional data, right? Here, essentially, you're like looking at this data from four different directions at the same time, while still getting the three-dimensional feel, because each of these shadows is cast onto one of the cube faces. ggcube also has a lighting system, which is for polygon-based layers. There's a bunch of flexibility in how you can specify lighting. I've only implemented, I guess you'd call them form shadows. It doesn't have cast shadows. So there's no like ray tracing happening where we know that one part of the scene is in the shadow of another part of the scene. It's only based on the orientation of an individual facet. But within that, a user can specify light direction, different lighting properties like contrast and whether it's modifying like value or luminosity. I have positional lighting, so like rather than all the light coming in parallel from outside the scene, you can specify a light source within the scene, and the light rays will sort of trace. Not I shouldn't say ray and trace. That's the light will project from that location. The light values can either be applied to like a uniform fill or color, or they can be blended with an aesthetically mapped fill or color. So like here in this bottom center example, right? I mapped this color gradient on the x-axis from blue to orange, and then I also applied lighting, and that gets blended with those mapped colors. I also have like an RGB lighting mode where the surface normal, so the direction of the direction that a given polygon is facing in gets mapped to a particular direction in RGB space, so that like every facet of the object is lit up with a different RGB color. So that's sort of the range of what you can achieve with a lighting system. Happy to talk in more detail about how that all works or some of the deliberations and options. It was very fun. This was the first like I had ever worked on lighting. I learned a lot and had fun playing around with it. And I'm like reasonably happy with where I ended up, but it's also one of the areas of the package where I feel like there is a lot of room for improvement. I know some people on the call here have a lot of experience thinking about this, so it'd be cool to chat more about that. I should mention, so lighting can either be added at the plot level. You can just do plus light to your plot and add a lighting specification that applies to every layer, or you can add light within an individual layer function call and it will apply only to that layer. With lighting, also kind of realized pretty quickly that when you blend light and shadow with an aesthetically mapped value, it can then be hard to tell exactly what the original color was before it got lit. So then I added this this way to add lighting aware guide so that you can actually see the range of lighting and shading that corresponds to a given color value, which I think helps with perception relative to having just a flat, unlit legend.
There's a question. I'll just ask it. It's from Andrew Costandy. Or Andrew, if you're available to jump in. Let's see.
Yes, hi, can you hear me?
Yeah.
Yeah.
So I just wanted to ask, is there a way to interactively rotate the 3D plot? Because sometimes it's difficult to know upfront which angle is best for viewing. So right now what I do is I try to use the chord 3D function and I try different, pitch, yaw, roll values. But it's kind of, it takes quite a while to try different values until you get a satisfactory view. So I was just wondering if there's a faster way.
Yeah, great question, and actually perfect segue into the next slide here. Um, so yeah, there's two ways to rotate plots. They both involve like building a plot first, and then either you can animate it or you can create it into turn it into an interactive rotatable widget. So this animate 3D function, you specify like a range of rotation values, and it will create a GIF or a movie with the plot rotating. This orbit 3D function lets you create like a drag to rotate widget. By the way, thanks to Gina for alerting me to this mammoth data set. So these are fit to this cool mammoth data set, which is a point cloud um, of like scan points of a mammoth skeleton, and then this is with geom geom hull 3D using an alpha hull. Um, so yes, you can rotate these things. I do think that's important, both for finding a single good perspective as well as for just letting users like explore the data and see things from multiple angles, which is of course one of the main ways you can mitigate some of the downsides of 3D. What it doesn't have is like it doesn't report out what the actual rotation parameters are for the spot where it is. So actually, it would be a good idea. Maybe we could do like a verbose version of Orbit 3D where it actually listed the rotation parameters so that you could scan through, find the one that best matched what you wanted, and then use that for a static plot.
That sounds
That
great.
would be
Yeah.
excellent. Thank you.
So yeah, that's a basic overview of kind of like the ground that ggcube covers. Um, there's a number of other like geometry layer functions and other things that I have thought about adding, but I think overall it's like as fully featured as I want it to be for initial release at least. Um, Now for the rest of the talk, I'll kind of talk about the underlying data transformation pipeline that the package uses to actually make all of this happen and some of the challenges I had along the way, like figuring out how to get it to all work, given the constraints of ggplot2's pipeline. So this is the basic ggplot build pipeline. I'm sure most of you are familiar with this on some level. When the user calls the plot function, things go through this series, the data goes through this series of transformations that go through the stat and the geom and train the scales and the positions, and then get into setting up the panels and the coordinate transformation before actually drawing the grid-based geometric components of the plot. This pipeline works really well for all the reasons, for all the like applications that ggplot2 originally was developed for, but it turns out that for 3D, there are a bunch of places where I kind of had to deviate from the original like intent of the pipeline, mainly related to the fact that the pipeline only gives individual methods access to certain plot level information at each step. So like the panel setup doesn't necessarily have access to all the information I need related to the 3D properties of the scene in order for me to set up the panels without kind of reaching outside the sanctioned communication channels that exist within the ggplot2 ecosystem. So I'll just kind of step through these quickly one by one. Data prep is basically totally native. There's nothing I had to do here. Once we get to the stat, this is where raw data get converted into some kind of visual shape that eventually will turn into the plot. The the key here is that like any kind of information that is specified at the layer level that came in through one of those layer functions, I'm attaching it to the data frame in the stat or the geom as a new column, so that then that gets passed through the pipeline with the data frame and can be consumed later in the pipeline by the method that needs it, right? So like if a user specifies lighting methods or depth sorting or other things in the layer function, or if the stat or the geom generates those, then there's this easy channel where you just kind of attach it to the data frame and it gets passed along and then can be used later in the pipeline. But contrast that with like some other things I needed where I couldn't really use that same pipeline to like move data from one place to another, right? So scale training, there's a lot of machinery in ggplot for training the X and Y scales. They're positional scales, so they're like a very special category of aesthetic relative to other aesthetics. That's not true for the Z variable, but I wanted the Z variable to act the same way as X and Y do. You know, my sort of guiding design principle was like to try and design this as if the Z aesthetic were a native part of ggplot2, which obviously there's good reasons that ggplot2 is only two-dimensional and it should stay that way, but I did want to make it sort of a native feeling experience. So for example, there's not really anywhere I could attach the Z scale information. So what I'm doing is creating like a cache in the package level environment where I'm sort of stashing this Z scale object, which then I can refer to later as I need it, rather than having it be like an integrated part of the plot build object itself. So these little purple arrows I put here are places where I kind of had to like do something hackish, possibly fragile, reaching outside the established pipeline in order to like get things to work for ggcube. Then we have position adjustments. So I talked about position on face. Basically this step, I'm just like tagging each row of the data, saying whether it should be flattened onto a given cube face that gets used later. Set up panel params is sort of the densest cluster of hacks that I had to do, reaching outside the sort of approved ggplot2 ecosystem in order to make things work. The main issue, so I guess one issue is that the scale expansion machinery in ggplot kind of happens automatically for X and Y. But in order to have scale expansion happen for Z in the same way as for X and Y, I had to use internal ggplot2 functions. There's a couple scale expansion functions that are not exported in the API of ggplot2, and so I had to use those internal functions. It works for now, but that's kind of fragile because those functions could change without notice, and then it would break ggcube. So that's one issue. The other issue is just like the setup panel params method doesn't have access to these other plot level pieces of information that I needed. So I needed access to the theme from this location so that I could like suppress the two-dimensional panel that would normally appear behind the data. I needed access to the light specification, which is another plot level thing, and the labels. Again, just like ggplot2 assumes that there's only certain pieces of information needed at a given step in the pipeline. And if you don't need that information, you kind of have to find a workaround. And in my case, the workaround was frame walking, right? So frame walking, basically there's a call stack where every function that calls functions below it has local variables, and you can actually walk up that call stack and find the local variables within a function that called you. Long story short, it's kind of like searching through the call stack to find the information that's needed. And that works as long as the internal names and structures of those objects doesn't change. But of course, that's fragile to like internal changes in ggplot2 down the road that could end up having these downstream effects that break ggcube. Then we have the three-dimensional coordinates transform method. This is like a very dense part of ggcube. This is where the three-dimensional data gets transformed into like a two-dimensional visualization, essentially. So this is where all the 3D stuff happens. Kind of zooming into this stage. First of all, we attach the light spec. So resolving the lighting specifications the user supplied. Some like bookkeeping with some of the z-scale coordinates for some kind of edge case type stuff. Then we take the native data scales, which could be in arbitrary units for the x, y, and z axes, scale those all into a unit cube. And then we're working in visual space. So starting to move from raw data space into visual screen space. Still 3 dimensions here at this point. Once we get it into this visual space, accounting for aspect ratios and scale expansions and things, then we can start computing light, right? When I first built ggcube, I was computing light in the stats and the geoms, but then I realized that like light is actually a visual space. There's some cases for like genuine 3D data, like maybe the mammoth, where it would make sense to calculate lighting in the raw data space. But for most things, like the units aren't necessarily going to agree. There's no latitude and longitude and elevation, for example, are on very different units, and it wouldn't make sense to like use those units to calculate light. So we calculate light in the visual space that the viewer sees as if like it's a model that's actually lit rather than the raw data being lit. And lighting computation happens based on, again, the surface normals, so the direction that a given surface is facing in three-dimensional space, and how closely those surfaces face the light source. So if they're facing directly toward the light source, they get a high lighting value. If they're facing away from the light source, they get a low lighting value. And then depending on like the lighting models and parameters that the user has selected, we modify the color of that polygon, either the fill color and or the outline color, according to the lighting model. Then moving on, so now that we're in sort of this space, we can flatten the data against the cube edges if we are projecting data to a given face of the cube. And then we can transform that three-dimensional data into the final like camera screen space. So some simple linear geometry, basically linear algebra, to like rotate and apply the depth perspective, gets us from the original XYZ axes into the like final XYZ axes, where X and Y are the screen units essentially. We also keep a couple variables related to the transformed z-axis. There's a depth variable that gets used for sorting, so that, obviously we want the more distant geometric components to like draw before the near ones. And then I mentioned this depth scaling also, where near objects, points and lines can be drawn larger. Then we finally transform into like the grid package's coordinate space. Do some backface culling, right? So polygon rendering in ggplot can be very slow if you have lots and lots of polygons. Backface culling is basically a way of like figuring out which individual polygons you don't have to draw because they're on the back side of an object. Right? If you have a sphere, you actually only need to draw the front side of the sphere. If it's solid, you don't have to draw the other half of the facets of that sphere. So we do some backface culling. And then depth sorting. So again, calculating which points to draw first. This turns out to be kind of a tricky problem that I've sort of partially solved in ggcube, but a still somewhat unsatisfying solution. So there's a couple algorithms I've implemented for doing the depth sorting. One is called the painter's algorithm. So like, let's say you have a sphere that's made up of a bunch of facets from a convex hull or something. The painter's algorithm is just like figure out the average distance from each of those little polygons to the viewer, and then sort by that average distance. That works sometimes, but also sometimes creates problems. So I also have this like pairwise sorting algorithm, where two objects that overlap in viewer space, we can actually like look at the little narrow area where they do overlap and see which one is closer. Then the pairwise and painter algorithms both work with like a mix of different geometric primitive types, so you can sort like points and polygons and lines all together. Again, this only orders the geometry within a given layer. There's no way to, at least that I've discovered, to do any depth sorting across layers. That would be super cool and would be like the real 3D native way to do it if you could specify multiple layers and have depth sorting occur across. But within ggplot, I could not figure out a way to have that happen. So all of the depth sorting is within a layer, and if you add another layer on top of it, it's all going to plot on top of a prior layer. So yeah, then getting into the final rendering. This next stage was it turned out like a lot of the development time went into this, rendering the background panels, right? So those panels that appear behind the data that give the plot its look and have the grid lines and the labels and all that kind of happens automatically for a two-dimensional native ggplot. But I had to implement all of that kind of from scratch for 3 dimensions. So based on the user's theme that they've specified, kind of figuring out what all of the parameters for a polygon should be to make one of those polygons that sits behind the data, and figuring out where the grid line should go. And then for the labels, like where do the labels go? How do I rotate them so that they're in line with the grid lines? The label spacing, all of that. So this is a big chunk of the like source code of ggcube is all this machinery for dealing with the panels and grid lines and all this stuff. It's not actually data itself. And then also like identifying which of these panels and grid lines and things sit behind the data and which sit in front of the data. Because we render the background ones first, then we render the data, and then we render the foreground panels. I have one kind of rendering engine that does rendering for all the primitives. So polygons, points, segments, text, all come from these different layer functions. I have one rendering function that handles all of those and kind of interleaves them with depth sorting, and also scales the point and line and text sizes based on the depth to give that additional perspective effect. Yeah, then finally we draw those foreground cube faces. I don't have any text here, but I did add an additional, so there's two ggplot2 functions that I masked. One of them was aesthetic, and the other one is element rect, right? The ggplot2's element rect doesn't have like an alpha parameter, so there's no way to control the transparency of those. And I wanted to have the user be able to specify that like they wanted the foreground panels to have a given opacity so you can see through the panels to see the data. And so I masked that with my own version of element rect that allows the user to set the opacity or the transparency on that. And then finally, assembling all those pieces into the G-table. The other thing that happens here, so there's a couple of things. So one is this is where the the color bar guides get shaded according to the light spec. So again, I have to reach outside of the like official communication channels within the pipeline here, walk up the frame to find the lighting spec from the rendering location, so that I can correctly shade the color bar according to the user's lighting spec. Um, and then there's axis titles. So in like base ggplot2 using grid, axis title placement is very, very nice. The title placement sort of scales perfectly with the size of the axis text, right? If the axis text is long, you can place the title further away from the axis so the title and the text don't overlap with each other. This turned out to be kind of a headache. I don't have a perfect solution to this here. So sometimes depending on the size of your graphics device and things, you'll end up getting like titles and text that overlap as far as the axis titles and text. I'm kind of using just an arbitrary constant that seemed to work overall to like offset the axis title based on the number of characters in the axis text sort of thing. But it would be nice to come up with a more satisfying solution. It is totally possible for the user to like adjust using the theme system to adjust the padding on the axis title. So like they can fix it if there is an overlap, but it's still like the defaults don't work perfectly every time. So that's an area that I'd like to ideally find a solution to. Um, so again, just kind of like final thoughts here. Like there are these you could call them hacks. They're these points of fragility where I am depending on the structure of internal ggplot2 code that is not part of the public API. And that leaves ggcube open to like breaking if ggplot2 internals change. There's a couple different instances of that. One is just, again, using a couple of internal functions explicitly, and then the other is this frame walking I had to do to access data that wasn't really shared at all in the pipeline. Again, there's like there is this general tool in the ggplot ecosystem for adding something to a plot. This ggplot add function makes it really easy to add something to the plot, but it doesn't make it easy to do the opposite, which is to read information from the plot level object at an arbitrary point in the pipeline. So there's a little bit of an asymmetry there that kind of made things challenging. So I guess if I had like some asks or a wish list, you know, there would be some small things like just exporting some of the scale expansion helpers that would help to remove some of the fragilities that I talked about. But then like a bigger ask would be to have some supported channel to let these methods like access plot level state variables arbitrarily rather than just the narrow subset of variables that like the original pipeline was designed to be accessible from a given point in the pipeline. So yeah, that's what I got for you today. That's kind of like my journey with ggcube. And yeah, happy to take any questions or comments or curious to hear folks' thoughts.
Yeah, thanks so much for walking us through that. A lot of beautiful figures to look at. And I think that, yeah, having this third dimension to work in and like something so consistent with the syntax that we know and love is great. And I had an opportunity to try some of this stuff out and really enjoyed it. So if there, yep, I see questions already. So we'll just dive into folks' questions. So Will, why don't you go ahead?
This was fantastic. Thanks so much, Matt. I swear at one point I saw a different 3D ggplot package, but I must be thinking of base R things or something. And so it's great to see this exist. It reminds me a lot of there used to be a ggturn package, which maybe some people here are familiar with the evolution and death of that package. which makes me worry about kind of the evolution and maintenance of this package. It sounds like you're doing a lot of kind of hacky things. Um, you're masking ggplot functions, and I know that's kind of what ggturn was doing a lot of, and it resulted in having to, every time there was a new ggplot release, doing a lot of maintenance work to get ggturn to work again with the new version of ggplot. And so I wonder if have you thought, it sounds like you've thought about this a lot in kind of what you were saying throughout the talk, but have you built it in a way that you think you've minimized the amount of maintenance you'll have to do for future ggplot releases or things like that?
Yeah, that's a great question, and definitely a real issue. I've tried to minimize it for sure. Wherever possible, I've worked through like the existing channels in the public API to the extent I could. I do worry that there will be more of a maintenance burden than I would like going forward. I think the strategies that I am using like basically will work, but it will require maintenance and upgrade if there's yeah if there's major changes to the internals, it could mess things up in a way that could require a lot of fixing. Ideally, that should be fairly minimal, but yeah, it would be nice not to have to do any of this hackish stuff and to be able to do it all, properly. But I don't have a great answer to that really. Other than that, I do worry about the same thing. And then to like address your first part, there was another 3D ggplot extension. It was called GG3D. It's no longer maintained, and it did some cool stuff, similar in some ways. It didn't provide its own new chord, so you kind of had to like add axes and things manually along with other layers, and it wasn't as like deeply integrated with all the other theme and scale aspects of ggplot. So I took some inspiration from that for sure, but this hopefully is a little more user-friendly and a little more flexible.
Cool. Yeah. I wonder if down the road you'd also be able to have some sort of ternary diagram uh, function that could replace ggturn, since I don't think it works anymore. Last time I checked, it was kind of dead. But
Yeah, I remember
anyways,
using
yeah,
ggturn many years ago, but I haven't looked at it lately, so I'll have to check that.
yeah. Thanks so much.
And Tyler did mention ggRGL, which looks like it's a quite cool but useless. It looks like it takes a different approach in I don't think it works by adding a coordinate system. It looks like it adds new geometries. And then, of course, Tyler's work like comes to mind, but I think it's your work like transforms. It takes a ggplot object and then projects into like 3D.
Yeah, as Matthew showed, I mean, there's an incredible amount of complexity in 3D rendering. So you really have to when you want to do 3D data visualization, you have the two choices where you either try to throw all the complexity into 3D rendering into ggplot, or the other way around is you just try to take ggplot and then get that object into a 3D renderer, which then it's a balance. ggplot provides and a lot of nice features, like you can take the output from Matthew's package and then create like a SVG or a vector graph or something like that, where you actually have the native output. You have the familiar interface, the familiar API. But yeah, then when you try to get the 3D parts in, that is you're going to be battling that the entire time. Which, yeah, there's been a bunch of attempts. GGRGL was one, but it was more of a, hey, let's see if we, again, take ggplot and kind of try to export it into a 3D interactive render. That wasn't mine, but that was another guy who tried the same thing. Yeah, and my attempt was just like, okay, well, I'm going to just take a subset of these things and then just grab the ggplot data and then put that into something that is much an actual 3D render. Eventually, what I think, Matthew, when you're talking about lighting, and that, when you start trying to put all these things together, it's one of those things where you're gonna, it's very hard to end up finding that exact, being able to generate good lighting. I think what you have here is actually great because there's definitely a need, I think, for these simple lighting models with the vector style graphics. I think that non-realistic but 3D rendering is very important because that fills a niche of like, hey, we have a vector style 3D visualization where it's usually somewhat the fact that it's somewhat cartoonish or somewhat not super realistic actually delivers the point of the visualization, which is like, hey, don't focus on the details. Which is when you get super hyper realistic with lighting, I think people tend to really start to focus on the details, which for a 3D plot is usually never the best idea because you've lost so much fidelity by going to 3D. But going to adding more lighting models, there's a lot of difficulties there because then when you start dealing with lighting in 3D, now you start getting shadows being projected against what's data versus what's just the shadow, and you sort of had this with your projections on the side, which is kind of like having a shadow being with a light projecting, and that does the shadows are very important because that actually allows a viewer in the two-dimensional projection to really be able to orient themselves, especially if they have sort of a flat substrate or some sort of that. The shadows can really give that missing 3D information. But yeah, trying to get all that functionality within an inherently 2D focused, in terms of the way it draws the vector data is not impossible, but it does provide limitations. And yeah, it's mostly you can see on having to figure out how to combine different data in this 2D plane to try to make it 3D. That's there's I would say the idea of combining multiple layers and that ordering is always going to be a hard problem in 2D just because it's not well specified. But focusing on the sort of more one at a time limited cases where you're not really trying to build a ton of data like together like meshes and terrain and all that, you can actually I think succeed at that pretty well. And then sticking with a more simplistic lighting model, I think would be that combination. I think would be very successful. But I also agree that the idea of having a interactive. I mean, with Ray Shader, that was sort of the big aha moment. Was no one wants to type in angles and be like, hey, does this work? Hey, does this work? Having something that actually you can move around interactively is just kind of critical for the user because I don't think anyone really thinks in terms of angles in real life. So having that and having some way to specify the lighting if you're doing that in a interactive way is also very useful. So, but that's my thoughts. I think it's very cool. I think there's a lot of space, a space of exploration in combining ggplot and sort of 3D rendering. I think the way you go around it though is always going to be if you're doing it within ggplot, you got to kind of say, well, what's the best thing that works with that? And I think it's more of these less complex but more diagrammatic visualizations. So those are all my thoughts. I think it's really cool.
Yeah, that's a good idea about like interactive lighting too. That is something in my own like plotting I've done with ggcube is like I can use the interactive features to like figure out what rotation I want, but then also there's the lighting position. If we could also integrate lighting into that interactive engine so that users could specify that too, that'd be super useful.
Yeah, I'm seeing that some folks are headed out and we are up like against the hour. I think we can keep the discussion going. Matt, if you're still available for a little while, since the presentation had so many dimensions to it.
Yeah, I'm
And
happy to stick around and chat as
great,
long as folks want.
great. We can run another 10 or 15 minutes. And folks, thanks for making it, Jeffrey and Will. If you do need to head out, understand that. Yeah, Corey, do you want to? jump in?
Yeah, thank you. This was great. I have a couple of questions that tie together, I think, that also tie to some of the discussion that's already happened. Will, I think, mentioned this commonality of the use of the Z position aesthetic in GG turn or in ternary diagrams as well as in 3D graphics. And so the question originally wanted to ask was or to what extent are there standards of good practice for 3D statistical graphics specifically, not just 3D visualization generally? And of the hacks or fragile solutions that you employ in ggcube and your asks of ggplot2 of exposing certain tools, do you see other areas, other types of graphics where those same exposures would be useful beyond like 3D graphics or beyond your specific extension?
Yeah, great questions. I would love to learn more about what the best practices are for like statistical three-dimensional graphics. I'm actually not sure. I probably should have done some more research on that before I undertook this project. There's a lot of sort of cautionary information out there from precise statistical communication thinkers about the risks of 3D and the downsides to 3D when you need precise communication. I've heard less about best practices if you do need to do it. Certainly, like interactive rotation and things like that, where you let the user see things from multiple angles, is one of the ones I've seen. Using multiple redundant visual channels to help encode some of the additional dimensions, right? So you could map color to Z as well as mapping a spatial dimension to Z, and then that provides some redundant information. Like if you think about a point cloud, right? Making the distant points smaller and a different color, and adds additional information that makes it easier for the viewer to tell like what is farther as opposed to closer. So there are some things that can be done there, but yeah, it would be great to learn more about that. I don't know if others on the call or if you, Corey, have thoughts on any of that.
Actually, one thing I will throw in so Joyce Robbins, who's unfortunately not here today, first connected with me. It was for a JSM event where another presenter, and I'm sorry, I'm blanking on her name right now, presented, I forget what these are called, but like tours in higher dimensional data where you sort of do rotations and you're projecting those rotations into 3 dimensions. So you're looking at higher dimensional data, but you're allowing yourself 3 instead of 2 dimensions to project it into. And the tours are a way of kind of exploring the different projections you get. That's something that I imagine would benefit from some of the new pathways you've proposed here, although I haven't worked with it myself.
Yeah, and then to answer your other question, like about whether there are any other packages or approaches that might also benefit from sort of like fixing those same fragility points that I encountered. I mean, I can certainly imagine that like something like GG Turn could benefit from having access to the scale expansion machinery that currently is like reserved internally for X and Y. Beyond that, I mean, I imagine that there's probably lots of potential ggplot extensions that could benefit from a more sanctioned way of passing information arbitrarily in and out of methods at different points in the pipeline. Right, a lot of the methods only have access to a certain subset of information, and the more you could open that up, I think the more flexibility it gives. So I imagine that it could be broadly useful, but I don't have examples off the top of my head for where it would like definitely benefit other packages.
So Ton has a couple of comments. Not sure about this subsurface scattering, if that
Well,
is
that was a joke.
um yeah, it sounds like a big model. But you've dealt probably most recently with the ggturn problems, and maybe you can speak to some of that as working on backward compatibility.
Yeah, so ggturn is kind of it takes some liberties, and as such, we kind of take ggturn as a sort of positive control for have we changed something in ggplot2. If ggturn doesn't break, have we really changed anything in ggplot? I mean, it's not ideal. I'll give it that, but ggturn, I think you strike the right balance between invading ggplot to get what you need versus overruling things. ggturn goes all in on overruling ggplot two systems, and when they go out of sync, all of ggturn is broken. So I think you're doing a very reasonable job here. Though, as somebody who maintains ggplot2, I'm supposed to be finger wagging at anything that goes on. But I think it's a really delicate balance you struck here. I'm amazed with what you can torture grit into doing, even though it's not made for doing 3D graphics. And I kind of would have anticipated that doing the axis labels and all of this would take a large chunk of effort, particularly because text is such an unwieldy thing to work with, given that it has an absolute size that you try to finagle into some relative space. So yeah, I wholeheartedly empathize with that struggle, because I also have that struggle. Should maybe share the pull request that I prepared at some point, which is just a pull request that just does away with hard-coded X and Y axes, so that you can add your own Z axes if you're doing 3D plotting. And that is a proof of concept just to see how invasive it would be to change everything in that sense, and it would be pretty invasive, which is why we didn't go with it in the end. Because basically we'd be imposing upon every pre-existing extension that they also should accommodate the possibility of alternate position scale. So that we didn't want to burden everyone with this just for so in this case the court system would dictate what counts as position scales, and we didn't want to impose our new idea upon everyone. But I suppose if we at some point when we are going to break court systems a lot, then we might as well also break this. So, but making a new break for this is a bit tricky for.
Yeah, that makes sense. Was ggturn the motivation for exploring that, or something else you were
Among
looking at?
other things, yeah.
Trevor, did you want to jump in at all? I see you have a comment here. Standard XY coordinates, only a subset of background. Within a oblique projection, you may want the standard XY coordinates only, a subset of background with extra space for a new Z coordinate in right top. Does that make sense to you, Matt, at all?
Trying to interpret it. I guess, right, with oblique coordinates, you sort of have like the z-axis shifted up and to the right a little bit, without any perspective projection, just sort of flattened up and to the right. But yeah, I don't fully understand the question or comment.
Okay, I'm not sure if Trevor, if you want to jump in, just let us know. I guess I'll ask a question about towards 2010. Okay. About like interoperability, and I feel like Corey's our interoperability guy on extensions. So I guess how do you think that extenders should think about ggcube, and are there opportunities for extenders to make their extensions interoperable? Should they be thinking in that direction, or?
Yeah, great question. Yeah, I mean, I think ideally a lot of other extensions should interoperate easily with ggcube, because I try to make it as like integrated with native ggplot as possible. Certainly, like it's easy to extend ggcube by adding new 3D layer functions, new stats and geoms and things like that. Should work sort of seamlessly with the existing system. Though I haven't like written any documentation for how you would write new layer functions, that is an easy way to extend ggcube. Yeah, I don't know. I haven't thought so much about how ggcube would work with integrate with other extensions. But
Yeah,
yeah,
I mean, actually the like dimensionality reduction work, and Corey does some like PCA work with ggplot2, and so like there's, I mean, to extend to ggplot2, like base ggplot2, it's like, oh, I want to project to 2 dimensions, but now we're in this space like, well, maybe we should be thinking about projecting to 3 dimensions, and I don't know, anticipate that people will also want to use the Z position.
right, right.
So yeah.
Todd, I see your chat. I don't have a list of those requests anywhere online, but I'd be happy to shoot you an email or whatever with thoughts or whatever the best channel is.
Yeah, if you post your slides, if you want to post them, we can get them up on the website.
Sure, yeah, I'm happy to.
Actually, if I
I mean,
can,
for simple things, it's simply putting up a ggplot2 issue might also be good. I mean, you can probably incorporate the scale expansion algorithm into the scales themselves, so you don't need to get from namespace, that kind of.
Yeah, that'd be awesome. Yeah, I can open an issue for that for sure.
All right, well, let's go off of the recording, and then we can just hang out for a few minutes. And then that'll be that. This was a great meeting. I really appreciate Matt, you talking us through that, and everybody for coming out. Let's see. So...
Yeah, great discussion. Thanks for the invitation. Let's see, Corey. Yeah, I think